Good so far.
Yeah.
If your name wasn't on the list for the project, because a couple people had added, they are now on there. So when you open it, you'll see your name. I went on and checked this morning who had added. And so under attendance, homework, and projects, here's an example. And then here's the kind of like a rubric or what's expected. And then which attraction you have. When you click on here, it will have it. So there was 2 people that added. They've been added on. Any questions on that?
Mine is the wait, Jeddah Lighthouse in Saudi Arabia, right? I'm just making sure. My name's Abby.
I think it is.
Okay.
I think there's
because I
only
already
one.
started.
What's your last name?
Mastrovito. Yeah.
Is that how you
Okay.
pronounce it?
Oh yeah, it says in Saudi Arabia. Yeah,
Okay. Thank you.
you're welcome. Well, since we have it up here. Oh wow, too small. There we go. So names are in alphabetical order, and here is the attraction that you'll be comparing with. But there was 2 people that I added in. I think also one dropped, but I'm not sure, so I just left it there. Any questions? To see an example, you would just click on here. I showed it last class. It's not my best example. I did it very quickly, so please try and do better than that example. You want for slideshows, I think that was the biggest question I've been getting, or for how many slides? Probably at least 5, because you'll have your beginning with all your measurements, and then the 3 items you're comparing with, and then a conclusion. Well, oh yeah, an interesting fact, and then a word cited. So, I mean, if you can cram it all into a couple, but it still looks really good, that's fine. I would think you'd have 5 or 6, but it's up to you. And if you have more, that's fine too. One student there's a couple bridges, but one had asked me about a bridge. It's the tallest bridge or the highest bridge, but she's also going to show in comparison the length of the bridge. And so if you wanted to do that with your item, you can do something like that too. Anything you want to add to it is fine. Any questions on that?
Nope.
Okay. We talked a little bit about section 1.1. Mostly what we talked about is humanizing, because that's what you have to do for your project. And we talked about the numerical and the measurement, or the unit. I forget what they call it. Yeah, the units. It's important to have units because otherwise you don't know what they were measuring in. I mean, if it's meters or yards, those are pretty close to each other, but a meter is a little bit larger. So you still need, if you need to be exact, you need to know what units they're using. When we need to convert units, and so for your humanizing project, you'll need to convert units. You can use a unit factor method. Whenever we multiply or divide physical quantities, we also multiply and divide their units. That way you're canceling units and you know that you're setting your problem up properly. So we'll do a couple. Express 1 million inches in miles. So 1 million. That would be 6 zeros because the first set is 1,000, the next one's 1,000,000. If you want further, 1,000,000,000 and then 1,000,000,000,000. So 1 million inches. And we want to go to miles. Well, I don't know how many inches are in a mile. I know how many feet are in a mile. How many feet are in a mile? Does anyone know?
500 or sorry, 5,280.
So we know that there's 5,280 feet in 1 mile. But we have inches. Well, we could go from inches to feet, and then we can go from feet to miles. So how many inches are in a foot? And if you don't want to say, you can type it in the chat. How many
12.
inches? There we go, 12. Yep. Now, when you're setting up that proportion, you want to set it up so that inches is in the top here. When you're canceling units, you have to have one on top and one on the bottom. That means we need to have the inches here. And the feet here. That way then our inches will cancel. And we said 12 inches is 1 foot. So this would be the unit factor method. We're setting up proportions to get to what we want, miles. But by setting it up, we know that we need to divide by this 12 instead of multiply. Now we have feet, and we said we could go from feet to miles. We want feet in the denominator so that they will cancel because this one's on top. So 5,280 feet is 1 mile. That way then our feet cancel and we're left with miles. So by setting up these little proportions, it's called the unit factor method. Now you could multiply straight across first. And multiply across the bottom. And then divide them. Or you could take the million divided by 12 and then divided by 5,280. Now you should get 15.78. And I probably could have put the line. Well, that's okay. And then it keeps repeating. 282828, or you could have went 8282. When you put a line over it, that means it keeps repeating. So we could have put it this way, or 15.782 repeats. Both of these mean the same thing. Because when I divided, you can think of it as repeating 82828282 or 282828. Just depends on where you're thinking to start the repeating. If we wanted to round to the 100th position. When you're rounding, you want to use this symbol, so now we know it's not the exact value, it was an estimate. And if we're rounding to the 100th, this first position after the decimal is the 10th, this 8 is the 100th. Since the next one is below 5, it stays an 8. So it would be 15.78 because this too. If we wanted to round to the 10th, that would be this one. So the 8 is 5 or larger, it rounds the 7 up. So it would be approximately 15 point. If I don't specify where to round it, give the exact value and then you can estimate. It's up to you. So if I don't state, then it would be up to you. Any questions on that one?
No.
Okay, let's try the next. Beefy Acres is a cow-calf farming operation located in the southeast. Used an example in a pamphlet published by the National Resource Conservation Service, a division of the U.S. Department of Agriculture. Beefy Acres has 20 acres of pasteurized land. And each acre produces 9,500 pounds of forage. Forage is the amount of grass that the animals can eat. To thrive, each cow requires approximately, so one cow equals 17,000 500 pounds of forage. Per year. And I believe this is also per year. So I always write down my information and my numbers first. Some of them I might need, some of them I might not need, but at least I have all my numbers and I don't have to keep reading a large paragraph. The other thing you could do is with a pencil or a highlighter, you can highlight the important parts or underline them. So then you're not rewriting them all also. What is the maximum number of cows that can be supported at Beefy Acres? So we know they have 20 acres of land. Notice the acres can get us, this one can get us to pounds, and pounds can get us to cows. So you want to think about those proportions. One thing that's good, if having values you're not comfortable with or units you're not comfortable with, if you do a lot of problems with time, that will help you be comfortable, because days, hours, minutes, seconds, we're comfortable with that. It's something we use all the time. So sometimes you might have to do that. But we'll start with 20 acres. Now we want to set up a proportion to get to pounds, because once we get to pounds, we can get to cows. We know 1 acre is 9,500 pounds of forage per year. I'll just click on here so we could see all of it. Think about the proportion, and then you want to think about which one would go on the top and which one would go on the bottom. Acres needs to cancel. So which one should be on the bottom? The 1 acre or the 9,500 pounds?
1 acre.
Yes,
I don't-
exactly. We put the acre on the bottom so that they will cancel. Now, whether they're plural or not, units don't have that. We don't need to worry about it. They just cancel. And the 1 acre is the 9,500 pounds per year. The per year is important because if it was per day, then we would have to change units because the other one is per year. Now we know that pounds per year, 17,500 of them is what each cow needs. So we can use that as our next proportion, but we have to decide which one goes in the bottom and which one goes on the top. So would we put cows or forage on the top?
Cows.
We want to put the cow on the top because we want this to cancel with the 17,500 pounds. So our acres canceled, our pounds of forage per year canceled, and it left cows. So when we solve this, it will tell us the number of cows. So how many cows can Beefy Acres sustain? When you get your answer, you could type it in the chat. Multiply 20 times the 9,500 times 1. 10 cows. And then when we divide, you should get 10.85714,286. But of course, we don't want part of a cow. Now, if we were doing normal rounding, this would be 11. But would we have enough grass and forage to feed this entire cow? We can do 10, almost 11 cows, but we can't round that one up because we don't have enough to feed the whole cow. We will run out. And that's why when we would round this one, it would be 10 cows. So on story problems, you need to be careful because you cannot always round to the nearest integer. So if we made that 11, we are rounding to the nearest integer. But we can't support that 11th cow. We don't have enough. Any questions on that? Now, when you're doing these story problems, I mean, the plain ones that we're doing where we're just converting things, you can just show your work and give an answer. But on these ones, you should write a complete sentence. Let me bring the question up again.
If I had to ask on our exams, how often would we have trick questions like this where it's all in the wording or like it's based on the integer.
Okay, so on a test, I would say be careful, round properly. So then you were thinking about it. If I didn't put something like that, I would accept both answers.
Okay.
I would not take off because of something like that on a test. But usually I'll put be careful, round properly, so that you're thinking about the story problem and but no, I would not take off if you put 11 cows. I might put can't really feed the 11th cow, but I wouldn't take off. So beefy acres can sustain 10 cows. It doesn't have to be anything huge, but you should always complete your answer in a sentence. Most of the time on a test, I'd remind you. Any questions on that?
No.
Okay, there are some tables in your book that break down units, which are kind of nice. The book under important information is right here. Okay, there we go. I'm not sure if it will show you all of your books, so make sure you're opening the right book because I noticed that mine shows both my classes. So make sure you are opening the Math 1010 book. Slow today. And then it said page 7. Nope, that didn't do what I wanted. Sorry. I thought it would close this. Okay, so page 7 towards the bottom, it gives you units. Seconds, snapping your finger would be a second. A heartbeat would be a second. Minutes are 60 seconds. It's also giving you the abbreviations, which is nice. And it's giving you a humanized example or something that you can kind of relate what a second is. Singing 5 verses of Row, Row, Row Your Boat. About the time you spend during a casual lunch, and so on. So it kind of gives you little estimates. The next page, it has length in US measurements. An inch is about the size of a paper clip. It's also about the size of your thumb. About the length of a large human foot. So if you need to measure the length of a room, your foot's a good way because it's approximately 12. If your foot's shorter, then maybe you want to take a little bigger step, but it still will give you a good rough estimate. The width of a single twin bed, I didn't know that one, is 3 feet. I go by my arm span is a little under 3 feet, one arm. your entire arm span from one finger to the other is approximately your height. A mile, about the distance traveled for 20 minutes walking. And then this group is metric system. We will definitely use centimeter a lot. The centimeter is about the width of your pinky. It's also the length of a carpenter ant. A meter is a little bit more than the twin bed because a meter and a yard are pretty close in length. A yard is 3 feet, a meter is 3.3 feet. So they're close. And then kilometer is 1,000 meters. So I would say I don't use the micron that much. Whoops. But these the bottom 4 for the metric system are ones that you should know. If there's one I use that you don't see as often, then I would put that into the problem. Another one you should know, although since it's not on here, I'd probably, unless it comes into another one, terabyte and gigabytes are used in computers, so it's stuff that you should know. And they might be in a different part. So those are those 3 tables. Let's see. Use the information from the tables to determine how long it would take to walk 3 million centimeters. Okay. So we have 3 million centimeters. Use this information to determine how long it would take you to walk 3 million centimeters. All right. One thing we could look at here, we have centimeters. If we went to meters and then to kilometers, we know that 1,000, we could just, 1 kilometer is about 12 minutes. And so 1,000 meters is about 12 minutes. So if we get to meters, then we can convert to time. Does everyone see what I mean? So by knowing that to go 1,000 meters is 12 minutes, if we convert to meters, then we can use this conversion. Let me bring my paper up.
How far are we going again?
We want to go to time. I'm trying to see. Wanted to shrink the time one, here we go. So we have 3 million centimeters. Now we can change it to meters. We know that 1 centimeter is 1 over 100 meters, or 1 meter is 100 centimeters. What we're doing is, if we have, write it down here, 1 centimeter is 1 over 100 meters. We can multiply both sides by 100. So then we have 100 centimeters is 1 meter. So if you're using these to set up and you don't want the fractions, then you can multiply the denominator to the other side. So like this one, the 1,000, then that means 1,000 millimeters is 1 meter. This one means 1,000,000 microns is a meter, because you're just multiplying the denominator to the other side. So we'll go back 3,000,000. I'm gonna put the number. 1,000 million centimeters. Now I know that 100 centimeters is 1 meter. Did I put the proportion in the right? Did I want centimeters on the bottom?
Yes.
Yes, because I wanted centimeters to cancel so I could convert to meters.
Flip
And
it.
then- Was there a question?
No, you flip it, right? But wouldn't you have to multiply by a negative? Or am
No,
I getting ahead of myself?
maybe. I don't need to flip it. What I did was here I multiplied the 100 to the other side. So now I know 100 centimeters is 1 meter. And I want centimeters to cancel. So this is multiplication, not an equal sign. 100 centimeters is 1 meter. And then looking at this last part of this table, 1,000 meters is 12 minutes. Right here. Now, when I'm deciding which one of these to put on the top, I want to get rid of meters. This one's on top, so the other one needs to be on the bottom. Then my meters cancel and I'm left with minutes. Any questions on that? Okay. Now, these are a bunch of zeros. We could plug all this into our calculator if we wanted, but when you have zeros on top and bottom, you can cancel them. This is 3 zeros, I can cancel 3. This is 2 zeros, I can cancel 2. So now I only have 30 times 12. 3 times 12 is 36 plus 1 0. 360 minutes. Any questions on that? Now, 360 minutes is kind of long. Maybe you want to change it to hours so that you can see it better. We know that 60 minutes are in an hour. So we would put minutes on the bottom so they'd cancel, and 1 hour on the top. The zeros are going to cancel. 36 divided by 6 is 6 hours. So it takes 360 minutes or 6 hours to walk 3 million centimeters. Any questions on that? What we
No.
did was humanized the problem because we got it to a smaller unit. We also converted it from distance to time by understanding that you could walk 12 minutes in a kilometer.
Well, we have to memorize like all the just the conversions, like how many centimeters are in a meter, and like, well, we have to memorize all that.
Some of them, you know, I'll make a sheet that has the ones that you should have memorized. And then if there's anything different from that, I would put that in the problem.
All right, that sounds
Okay.
good. Thank
Yeah,
you.
I try and use the most common ones, centimeter, meter, and kilometer, when it comes to the metric system. The mile to the yard, I don't always memorize that one because I know miles to feet and I know I can get to anything else from that.
Right. Okay, thank you.
You're welcome. Any other questions so far? I think there's another one to. To express the measurement, and we talked a little bit about this. There are a few rules though, and sometimes you can't follow those rules, and that's fine. But you want to try and follow them if possible. Now, if I said humanize this using both sets of rules, then that would be different. But in most cases, you can get into this. So when you are doing that, you're trying to find something that is close to 1 or between 0.01 and 1,000. Like this one was 3 million. We got it to 360, which isn't bad, but 6 hours is a lot easier to visualize than 360 minutes. So if you can get it closer to something that's easier to see, then that's a good idea. If I just said, get this into time, it would be up to you if you did minutes, hours. I don't think you'd do days because it would be part of a day. So you want to try and find a value that's between 0.01 and 1,000. It's hard to visualize more than that. Use human scale units like feet, inches, hours, people, house, car. It does not have to be a measurement. Something people are familiar with. You want to be careful not to use something that is not, most people need to be able to know about it. But I wouldn't take off. I might ask you, what is that? Or I'll Google it, but when these rules both apply, it's hard to express something. It's not hard to express it in human terms. For instance, if you think about the studs in a home, they're about 16 inches apart. This is a small number on a human scale. But if we were expressing it in nanometers, 406 million nanometers, that it's hard to visualize that, but 16 inches, you can. And again, if we went into miles for the distance, it's so small, it's hard to visualize. And that's why we try and humanize it. Sometimes it's in the regular measurements that we know, sometimes it's in elephants or panda bears. The human heart expands and contracts roughly 1,000 times a day. How could we humanize this value?
Divided by 24, divided by 60.
Okay,
Should give you about 69.4 repeating.
What are we converting it to?
First 2 hours, then to minutes.
Okay, now if we did that, it's going to make the number larger. So if we have 1,000, whoops, 100,000.
Well, it's saying 100,000 a day. So that's the total for the day, right?
Right. No, it's 100,000 beats a day or per day. So 100,000 beats in a day. We could convert it to years. Because if we go smaller, it's gonna make it even larger. Do you see what I mean?
Then I did this backwards because I divided by 24 to try to get the number of palpitations per hour.
Oh, you're right. Sorry. Because one day would be 24 hours and that would make it smaller.
And then that's when I divided by 60 to get per minute. And that's when I got 69.4 repeating.
Okay. Because here the days will cancel. And then we know that 1 hour is 60 minutes. Now let's look at what number we get. Is there any questions on setting this up? Because our hours will cancel and we'll have beats per minute. When you're doing a rate, this would be a rate of change. Beats per minute, per means divide. So beats a day means day would be in the bottom. You got 69.4. 69.
Yes.
And the 4 is repeating, so I'm just going to put a line over it. So 69 beats per minute.
Wait, so to solve it, you so you take I'm just making sure I'm doing this right. You
Mhm.
take the 100,000 beats and then you divide it by 24, right?
Mm-hmm.
And then you multiply it by 60,
The 60 is still on the denominator. It
right?
would also be divided by. Now, what you could do is multiply across first. And we get the 100,000 over, and then 1 times 24 times 60. So you could multiply across your fractions first, the top and then the bottom, and then divide them.
Oh, okay. I think that would be easier for me probably.
Yeah, I think it's a good idea because then you don't miss, like if we had a 2 down here or something, it's less likely to get missed. So if you multiply all the way across first and then divide.
Okay. All right, I'll do that. Thank you.
So we have 69 beats in a minute. If that would be, sounds pretty quick, 69 of them in 1 minute. What happens if we change it to seconds?
It's 1.67, I think. And it's like 6704. It's quite the number.
So it would be
1.157407 with the 407 repeating.
Yep. Because we'd have 1 minute is 60 seconds and we want the minutes to cancel. This is on the bottom, so it's going to divide. So 69. 4 divided by 60. Now, when you're doing these, even though we put it this way, try and keep the whole part in your calculator until the very end. Don't keep like rounding because then you'll lose units. 7. And this keeps repeating 407. So it's beats per second, which means approximately 1 beat every second. So when someone says that you beat 100,000 times, your heart beats 100,000 times in a day, I could see that. I could see it beating once every second. But when you tell me 100,000 beats in a day, it's hard to visualize. So when you can break it down into something like 69 beats in a minute or approximately 1 beat every second, it makes it a little easier to visualize. And that's what you're doing when you're humanizing a value. So a value is too large or too small, you want to make it somewhere between 0.01 and 1,000. So this one would have also been fine to stop here, but I think this one was a little bit easier to visualize. Any questions on that?
No.
Over a lifetime, 70 years, the heart beats more than 2.5 million times with no pit stops for lube jobs or repairs. Does this make sense? So if we know we beat approximately 1 beat every second, in 70 years, could we have beated 2.5 billion times? Well, we could start with this and then work back, or we could start with this and go to years. It's up to you. I mean, this had a little estimate. Say that again.
I said, it sounds right.
It does. It sounds pretty close. Now to check it, this one had an estimate in it. We rounded here. So maybe we want to go back to the problem and use this rather than our estimate, because our estimate could be off. But we could start with this 100,000 beats in a day. So the whole part of this class is finding, when you're reading an article and it has numbers that you're like, that can't be, to be able to have a thought process to see if it does make sense. This was an article that was in a paper at one time, and it's a good one because we're comfortable with time to work out and see if it makes sense. So they said 100,000 beats in 1 day, and we agreed with that because we said it's approximately a beat every second, a little bit more than a beat every second. So we were satisfied. So then we're going to start with this again. And we're going to convert it to years, so then we can find out how many in 70 years. And I have the wrong beats. I don't know. I spelled that wrong. Oh no, they have it. Spell check. Okay, 1 day. Well, we can go to years. How many days are in a year?
365.
Yep. And was I correct to put days on the top?
Yes.
Always have a pencil in case you need to erase it. But you do want days on the top so that they'll cancel. Now we have years. And we know we want 70 years for 1 lifetime. So you could even make this a proportion so that you know if you should be multiplying by that 70 or dividing. The 70 is years, so these will cancel, and 70 years is 1 lifetime. So this will give us, once we calculate it, beats in a lifetime. So by using these proportions, it helps you set up the problem. So then if we multiply across 100,000 times 365 times 70 is a lot. 2555, and then we have 1, 2, 6 zeros.
Yeah.
And that would be beats in a lifetime. No, they said 2.5 billion. This is 1,000 million billion. We have 2.555. They're just rounding it. So you could approximate that as 2.5 billion. 2.6 billion would not be wrong either. But I could see how they left it as a 5 because these are pretty large numbers. I would accept either one. Even 3 billion would be acceptable. Unless it states what to round to. Is there any questions on that?
No.
That's it for today. Let me make a note so I remember where to start. Table 6. Okay, if you do not have any questions, I will see you. Oh, it's Wednesday already. I'll see you Friday.